Hello, in this lecture we will find the area of the yellow circle. You can see in the picture semicircle, and the yellow circle is inside the semicircle, and the center of the semicircle is at point O, and the yellow circle touches the semicircle at point P. Let's call the center of the yellow circle M, and we will connect points M and O together by a straight line. Actually, MO is the radius of the yellow circle. I will call it R because it actually starts from the center of the yellow circle and ends at point O, that is a point on the semicircle itself. For that reason, MO is defined as the radius of the semicircle. Any line segment that starts from the center of a circle and ends at any point on the circle itself is defined as the radius of a circle. For that reason, MO is the radius of the yellow circle. Okay, and we know that the segment line PQ equals to 7 times root 2 units. Okay, actually we have a rule. I will call it rule number 1. Rule number 1 states that if two circles touch each other, then actually the two circles can touch each other internally or externally. Okay, if two circles touch each other either internally or externally, then the point of contact lies in the straight line joining their centers. Joining their centers. Okay, now I will read again rule number 1. So according to rule number 1, if two circles touch each other either internally or externally, then the point of contact lies in the straight line joining their centers. Okay, so now I will explain the meaning of the rule number 1. In our specific example, we have the yellow circle that touches the semicircle at point P. Okay, and point P is also called point of contact, and rule number 1 states that the point of contact lies in the straight line. Which straight line? The straight line joining their centers. So rule number 1 says that the point of contact, that is to say point P, lies in the straight line joining their centers. So we have point M, that is the center of the yellow circle, and we have also point O, that is the center of the semicircle. So the rule number 1 states that the point of contact P lies in the straight line that joins their centers together. Okay, so point P together with points M and O create a straight line. Okay, so according to rule number 1, points P together with points M and O creates a straight line, that is to say OMP is a straight line, or we can say also PMO is a straight line, because rule number 1 states that the point of contact lies in the straight line. Which straight line? The straight line that joins their centers together. So the straight line is PMO. This straight line joins their centers M and O together. So point P lies in the straight line that joins their centers together. That is to say, PMO is a straight line. Or in other words, also PO is a straight line. Okay, again, if two circles touch each other internally or externally, in our case the yellow circle touches the semicircle internally at point P, Then the point of contact, that is to say point P, lies in the straight line joining their centers. That is to say the point of contact P lies in straight line. Which straight line? The straight line that joins their centers together, that joins point M and O together. So point P lies in straight line that joins the centers M and O together. That is to say PMO is a straight line. Or you can also say that PO is a straight line. Okay, we can write down that PO is a straight line according to rule number 1. Okay, PO is a straight line. So actually MP is also the radius of the yellow circle, because again it starts from the center of the yellow circle and ends at point P, that is a point on the yellow circle itself. For that reason, MP is the radius of the circle. I can call it R. And also, as you can see, PO equals to 2 times R. PO equals to 2 times R. That is to say, PO equals to the diameter of the yellow circle. So PO is a straight line according to rule number 1, and also PO equals to 2 times small r. PO equals to 2r. That is the diameter of the yellow circle. The diameter of any circle is defined as 2 times r. Okay? And because of the fact that PO is a straight line, we can say that OP is the radius of the semicircle, because it starts from the center of the semicircle, that is to say from point O, and ends at point P, that is a point that is on the semicircle itself, and that is exactly the definition of radius of a circle. So we can call it capital R. So capital R is the radius of the semicircle, while small r is the radius of the yellow circle. So I will write down that R, or capital R, is the radius of the semicircle, okay, r is the radius of the semicircle. I will explain again why, because actually OP, that is equals to capital R, starts from point O, that is the center of the semicircle, and ends at point P, that is a point that is on the semicircle itself, and that is the definition of a radius. So OP is the radius of the semicircle, and it is called capital R. For the same reason, also OQ is the radius of the semicircle, and call it capital R also. For the same reason, OQ is a line segment that starts from the center of the semicircle and ends, that is to say, from point O, and ends at point Q, that is a point on the semicircle itself. Therefore, it is defined as the radius of the semicircle. Okay, again, because of the fact that line segment OQ starts from the center of the semicircle and ends at a point that is point on the semicircle itself, it is defined as the radius of the semicircle. Therefore, I called it capital R. So we have OP, that is the radius of the semicircle, and we have also line segment OQ, that is also the radius of the semicircle. Okay. Actually, we have another rule. I will call it rule number 2. Rule number 2 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So I will read rule number 2 again. Rule number 2 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. Now I will explain rule number 2. So actually, rule number 2 states that if we have a radius, let's call it R, and we have tangent to that radius, let's call it T, then R, the radius R, is perpendicular to the tangent. Again, the radius R is perpendicular to the tangent T. That is to say, this angle equals to 90 degrees, and also this angle equals to 90 degrees. Again, in any circle, a radius and the tangent to that radius are perpendicular to each other. So this angle is 90 degrees and also this angle is 90 degrees. Okay, so actually we can implement rule number 2 in our circles, because you can see in the picture line segment MO, that is the radius, and actually OQ or QO is tangent to that radius. According to the equation, OQ is tangent to the radius MO. Therefore, according to rule number 2, this angle is 90 degrees, or angle POQ equals to 90 degrees. And also we can say that angle POL also equals to 90 degrees. So because of the fact that we have the radius MO and tangent to that radius, that is QO, actually they perpendicular to each other. That is to say, the radius is R is perpendicular to the tangent. That is to say, angle POQ equals to 90 degrees, and also angle POL equals to 90 degrees. So actually we have a triangle POQ that is a right triangle, because the angle POQ of the triangle equals to 90 degrees. Therefore, triangle POQ is a right triangle. So I will draw again the right triangle POQ. As you can see, side PO of the right triangle equals to R, and also side OQ equals to R, the radius of the capital R, the radius of the semicircle, and also side PO equals to R, that is the radius, capital R, the radius of the semicircle. And we also know that the hypotenuse of the right triangle equals to 7 times root 2. Okay, so I will draw again the right triangle POQ. So I drew again triangle P, the right triangle POQ, PO equals to capital R, OQ also equals to capital R, and the hypotenuse of this right triangle equals to 7 times root 2. So as you can see here, we can implement the Pythagorean theorem in order to find out the value of capital R. So I will write the Pythagorean theorem. So the Pythagorean theorem states that the square of the hypotenuse that is to say, the square of PQ. PQ is the hypotenuse in this right triangle. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. We'll read again the Pythagorean theorem. The Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually in our specific right triangle, and it is correct only in the right triangle. I will add that correct only in right triangles. Okay, so in our right triangle, the square of the hypotenuse, that is to say PQ square, equals to the sum of the squares of the perpendiculars, that is to say OP square plus OQ square, or PO square equals to OP square plus OQ square. Okay, so I write down the equation. PQ square equals to PO square plus OQ square. Okay, PQ square equals to PO square plus OQ square. I will call it equation number 2 because equation number 1 is actually, you can see it from the picture itself, we know that OP equals to 2 times R. We arrive to the conclusion that OP is the diameter of the yellow circle. That is to say, OP equals to 2 times small r. But we also know that OP equals to the radius of the semicircle. OP equals to the capital R. Okay? We also know that OP equals to capital R. Okay, so from equation number 1 and 2, we can deduce that R, capital R, equals to 2 times small r. Okay, so the first equation will be capital R equals to 2 times small r. That is the first equation. And okay, it is very simple. OP equals to 2 times small r, but OP equals to capital R. For that reason, OP equals to OP, and capital R equals to 2 times small r. And the second equation is the implementation of the Pythagorean theorem in our right triangle. So we will return to our second equation. As you can see from the picture, PQ equals to 7 times root 2. So PQ square will be equal to 7 times root 2 square. That equals to PO square. PO is R. PO is R. So PO square is R square plus OQ square. OQ equals to R. So OQ square equals to R square. So I will repeat again. In the second equation, PQ square equals to PO square plus OQ square. I substituted PQ by 7 times root 2 because PQ equals to 7 times root 2, and here we have square, so we squared also 7 times root 2, and we have here PO square. As you can see here, PO equals to R, so PO square will be R square, and we also have plus OQ square in the second equation. And as you see, in the drawing OQ also equals to R. So OQ square will be equal to R square. Okay, so in total we got for the second equation that 7 times root 2 square equals to R square plus R square. Okay, but R square plus R square equals to 2 times R square, and 7 times root 2 square equals to 49 times 2, because 7 square equals to 49, and root 2 square equals to 2. So I will write it down. I will repeat again. 7 times root 2 square is actually 7 square, that is 49, times root 2 square equals to root 2, and R square plus R square equals to 2 times R square. Now we can divide equation 2 by 2. We will get that 49 equals to R square. Okay, here we divided equation number 2 by 2. 49 times 2 divided by 2 equals to 49, and 2 times R square divided by 2 equals to R square. Here we will take out root from equation number 2. We'll take out root from equation number 2. So root of 49 equals to 7, and root of R square equals to R. Actually, the root of 49 is also equals to negative 7, but but in our case it is impossible that the radius will be equal to a negative number. So for that reason we will take into account only the positive answer, or the positive root of 49, that is positive 7. So the radius of the semicircle equals to 7 units. But we also have equation number 1 that states that R equals to capital R equals to 2 times small r. So I will write it down again. According to equation number 1, capital R equals to 2 times small r. Okay? So in equation 1, R equals to capital R equals to 2 times small r, we can substitute capital R by 7, because capital R equals to 7. Okay? So we substituted in equation number 1 r by 7. Here we can divide the equation by 2. We get that so we divided the equation by 2. 7 divided by 2 equals to 3.5. 2r divided by 2 equals to r, or small r. Small r, 2 times small r divided by 2 equals to small r, and 7 divided by 2 equals to 3.5 units. So the radius of the yellow circle, that is to say small r, equals to 3.5 units. Okay, the radius of the semicircle equals to 3.5 units. Now we have the formula for the area of a circle. I will call it equation number 3. I will call the area capital A. The area of the circle will be called capital A. So A equals to pi times r squared. Okay? So the area of the yellow circle equals to pi times its radius squared. But we have already found that the radius of the yellow circle equals to 3.5 units. So we can substitute r in equation number 3 by 3.5 units. So we will do it now. We will get that the area of the yellow circle equals to pi times 3.5 squared. Okay, so I substituted the area of the I substituted the radius of the yellow circle by 3.5 because the radius equals to 3.5 units. So now 3.5 units squared equals to 12.25. Pi times 12.25, because 3.5 squared equals to 12.25, and pi times 12.25 equals to 38.48 units. So we actually found out that the area of the yellow circle equals to 38.48 units. Okay, so the area of the yellow circle equals to 38.48 units. Okay, so now I will summarize the lecture. So we actually, the question was to find out the area of the yellow circle, and we actually know that the formula for the area of the circle equals to pi times r squared. R is the radius of the circle. So the only thing that is missing in order to find out the area of the yellow circle is the radius of the yellow circle. So the only thing that we have to do in order to find out the area of the yellow circle is to find the radius of the yellow circle. Okay, so actually the yellow circle is in the semicircle, and the center of the semicircle is at point O, and the point of contact between the yellow circle to the semicircle is at point P. And actually we defined M as the center of the semicircle, and we connected points M and O together. And as you can see from the picture, MO is the radius of the yellow circle, because it starts from the center of the semicircle and ends at point O, that is point on the yellow circle. For that reason, MO is the radius of the yellow circle. And we also note that the size of the line segment PQ equals to 7 times root 2, and we actually have rule number 1 that states that if two circles touch each other either internally or externally, then the point of contact lies in the straight line joining their centers. So actually the yellow circle touches the semicircle at point P, so point P is point of contact, and according to rule number 1, the point of contact, that is to say point P, lies in the straight line joining their centers. So point P lies in straight line. With straight line, the straight line that joins the centers M and O together. M is the center of the yellow circle and O is the center of the semicircle. So the line segment that joins the two centers together, that is to say MO, together with point P, the point of contact, these 3 points together create a straight line. That is to say PMO is a straight line. Again, the point of contact, that is to say point P, lies in the straight line joining their centers. So the point of contact P lies in straight line that joins the centers together. So point P together with the line segment MO that joins the centers together form a straight line. That is to say PMO is a straight line. Okay, so according to rule number 1, PMO and also PO, it is the same, is a straight line. Okay, so we can see from the picture that also MP is the radius of the yellow circle because it starts from the center of the yellow circle and ends at point P, that is a point on the yellow circle itself. For that reason also MP is the radius of the yellow circle, and as you can see from the picture, actually OP is the diameter of the yellow circle because it equals to 2 times R. Okay, OP is the diameter of the yellow circle. Or you can deduce it by the fact that okay, you know that OP is a straight line, but OP consists of 2 segments. Segment OM, that is the radius of the yellow circle, and also segment MP, that is also the radius of the semicircle. That is to say, 2 times R equals to OP. And any line segment in the circle that equals to 2 times the radius of that circle is defined as diameter. Therefore, OP that equals to 2 times R is the diameter of the yellow circle. That's all. And because of the fact that OP is a straight line, we can define also OP also as the radius of the semicircle, because of the reason that it starts, line segment OP starts from the center of the semicircle and ends, that is to say from point, starts at point O and ends at point P, that is point on the semicircle itself, and this is exactly the definition of a radius. Okay, so for that reason OP is also the radius of the semicircle. We called it capital R, and actually OP equals to capital R, but OP equals also to 2 times R, 2 times small r. Therefore, we can deduce from it that capital R equals to 2 times small r. So the relationship between capital R to small r is that capital R equals 2 times small r. Okay, so we know that OP is the radius of the semicircle. We called it capital R, but we also know that OQ is also the radius of the semicircle, because it starts from the center of the semicircle and ends at point Q, that is point on the semicircle itself. For that reason, OQ is also the radius of the semicircle. So we have 2 radiuses of the semicircle, OP and OQ, and we also, according to rule number 2, in any circle, a radius and the tangent to that radius are perpendicular to each other. So if we have radius, we call it R, and the tangent to that radius, then they are perpendicular to each other. That is to say, this angle is 90 degrees and also this angle is 90 degrees. And actually we implemented rule number 2 in our circles, because we have line segment MO, that is the radius of the yellow circle, and also we have tangent OQ to the radius. So we have radius and tangent to that radius. Therefore, the radius is perpendicular to the tangent. MO is perpendicular to OQ. So angle POQ equals to 90 degrees, and also angle POL equals to 90 degrees. Because of the fact that in any circle the radius is perpendicular to its tangent, therefore we can deduce that angle POQ equals to 90 degrees, because the radius is perpendicular to, that is to say MO, is perpendicular to the tangent, that is to say OQ. Therefore, the angle between them is 90 degrees, that is to say POQ equals also to 90 degrees. So I drew again the right triangle POQ, and PO equals to the radius of the semicircle, and also OQ equals to the radius of the semicircle, and also it is given us in the equation that PQ equals to 7 times root 2. Okay, so here we implemented the Pythagorean theorem in order to find out the value of the radius of the semicircle. And as you already know, according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And it's only correct on right triangles. So the square of the, in this right triangle POQ, the square of the hypotenuse, that is to say 7 times root 2 square, equals to the sum of the squares of the perpendiculars. That is to say 7 times root 2 square equals to r square plus r square. Okay? Okay? PQ equals to 7 times root 2, we squared it, and it is equals to PO squared, it is PO equals to R, so it is R squared plus OQ squared, it is also R squared, because OQ also equals to R. But we have already found out that capital R equals to 2 times small r, and again, according to Pythagorean theorem, the hypotenuse squared, that is to say 7 times root 2 square, equals to r square, that is the square of the perpendicular, plus the square of the other perpendicular. Both of the perpendiculars equals to r, so it is r square plus r square. And we actually found out that the value of the r, that is the radius of the semicircle, capital R equals to 7 units, but we have already know that capital R equals to 2 times small r. So we can substitute capital R by 7, because capital R equals to 7. So we found out that 7 equals to 2 times small r, and at the end we found out that the value of the radius of the yellow circle is 3.5 units. But according to the formula for the area of a circle, the area of a circle equals to pi times r squared, pi times the radius of the circle squared. But we already know that the radius equals to 3.5 units, so we can substitute r by 3.5 units. Okay, so we put the value of r in the equation, and at the end we found out that the area of the yellow circle equals to 38.48 units. Okay, so the area of the yellow circle equals to 38.48 units. Okay, that is the answer to the question. Okay, thank you very much.